So solving quadratics using quadratic techniques. So quadratics means our highest exponent is a square. Okay. Quadratic form we usually say is ax squared plus bx plus c. Instead of using x's here, that we're just going to use u's. So au squared plus bu plus c. We're using u's here because typically we don't use u's in our simplifying expressions. And so it's a good variable to use to do some substitution with. So for each of these, they're not in quadratic form, but we need to make them in quadratic form. So we need to make the first term be something that's squared, the middle term be something that's to the first power, and your last term is just a number. So our first equation is x to the fourth minus 16x squared plus 60. So this is not a quadratic because currently the highest exponent is 4. Okay. We want the highest exponent to be 2. Our middle term here is x squared, and we want it to just be to the first power. So we're going to use something called u substitution to write it into the quadratic form. What u substitution does is, for this one, we would let u equal x squared. If u equals x squared, I can substitute u in for every x squared that I see, and then we will have a quadratic. So if u equals x squared, instead of x to the fourth here, that would be u squared. Right? Because there's two x squareds in there, so it'd end up being u squared. Minus 16, instead of writing x squared, we're just going to write u, and then plus 60. Now this would be in a quadratic form because we have the second power, the first power, and no power.
How do you let the x squared? How do you let u be the x squared for x to the fourth?
Well, we want the x to the fourth to be something that's squared. So we wouldn't.
Because you have 2x squared.
Correct.
So u squared. Okay.
Correct. So and this is your full answer, telling what u should be equal to, and then the quadratic written out with the u. And then from here, if we were to solve this, you could easily factor this. You know how to factor things that have a power of a square. Now the other thing is, the only time this will work is when there's a certain relationship between our two powers here. So there has to be a relationship in those first two terms. So there we have a fourth power for our first term and the second power for our middle term. What's that relationship between the 4 and the 2? It has the same type of relationship here. This is the second power, that's the first power. What's the relationship between your powers? There are your powers, 2 and 1, 4 and 2. What's the relationship? Yeah, they're half of each other. So the middle term is always half of our highest exponent, or our highest exponent is double the middle term. If it's not like that, then it won't work. We won't be able to use this technique to help us solve it. So what we're going to do is we're going to write this in quadratic form if it's possible. So we always want our highest exponent to be a square. Okay, so we're going to have to let u equal various things in order to get our highest exponent to be a square. So number 1 is x to the fourth plus 13x squared plus 36. So what will I have to let u equal here so that our highest exponent is a squared? Yeah. So we will let u equal x squared. If u equals x squared, what is our quadratic then? Yep, and there's our quadratic. And that whole thing is your answer, what you're letting u equal to and the quadratic written out. Right now we're just writing this as a quadratic, so we won't need to factor. We'll be solving them in a little bit, and we will be then. All right, number 2, 16x to the 6th minus 625. So what's this one missing? It's missing the middle. We can still write this as a quadratic even though it's missing the middle power. What would the middle power have to be here if this first power is x to the 6th? Yep, x to the 3rd. So what should we let u equal here? X to the 3rd. And if u is x to the 3rd, what would our quadratic be? 16u to the 2nd minus 625. It's u squared because if we're letting u equal x cubed, there's 2 of those and x to the 6th, so we would have a u squared. All right, number 3, 12x to the 8th minus x squared plus 10. Yeah, u would have to be x to the 4th. Is that what our middle term is? Right now, what's our middle term? So is this one possible? No, this one is not possible. Because in order for our first term there to be a quadratic, u would have to be x to the 4th, and it's not. And that's not what our middle term is. Okay, so number 4, x minus 9x to the 1/2 plus 8. We can do with rational exponents. That's no big deal. What would we have to let our u equal? Yeah, let u equal x to the 1/2. And then what would our quadratic be? If it's x to the 1/2, we would have a u squared minus 9u, yeah, plus 8. If you're letting u equal your x to the 1/2, don't use x's again in your next equation. Otherwise, when you go to solve it, you're going to get a little confused. All right, is this okay just writing it as a quadratic? Okay. So now we're going to solve each equation. We're going to use whatever method we wish to. So for some of these, we're going to use u substitution to write it as a quadratic. Others of these, we will have to remember other ways how to factor, how we've learned how to factor earlier in the year. But you can solve using any method you want to use. So problem 5 is x cubed plus 343 is equal to 0. Well, we can't really put this one in the u form because it's an x cubed. Now, if this were an x to the 4th or an x to the 6th, that would certainly be a much better option, but we can't do that here. So instead, we have to dig back into our minds as to factoring. Is 343 also a perfect cubed? It is. So we have to remember how we factor sum of cubes. We factor sum of cubes. If a cubed plus b cubed, if that's what we have, which is what we have, it factors to a plus b times a squared minus ab plus b squared. We did that. I'm sure you don't remember the formula because I gave you the formula, but hopefully you remember using it. Well, if we subtract over the 343 and then we cube root it, we're actually missing out 2 of our answers. We would get 1 of the answers, but we would not get 2 others that would work. So we're going to factor this out. So what is 343 a perfect cube of? What is it? Yeah, it's a perfect cube of 7 cubes. This is like x cubed plus 7 cubed. Okay, so let's use our sum of cubes here formula. So if we have x cubed plus 7 cubed, what would be in our first parentheses here? Yep, x plus 7. Times, next parentheses. X squared, yep. Minus 7x plus 49, yep. So we have these two parentheses being multiplied together. That equals 0. So that tells us one of the two are 0. So it's x plus 7. If that is equal to 0, what's one of our solutions? Yep, negative 7. So that's one of our solutions if x plus 7 is 0. If x squared minus 7x plus 49 is 0, we're going to have to find the solutions from that. Now that can't be factored, so we can do the quadratic formula. You should all still hopefully have this memorized. X equals negative b, right? So what's our negative b for this portion? 7, yeah, plus or minus the square root of b squared would be, yep, negative 7 squared is 49 minus 4ac. So 4 times 1 times 49. Yeah, 196. Then all over 2a. So 2. All right, 49 minus 196. What is that? Negative 147. Okay, so the square root of negative 147. It's definitely an I in there because it's the square root of a negative. Is there a perfect square, though? Yes, there is. What is it? 49, so this is 7i square root of 3 all over 2. That can't be simplified, so that would be our other two answers. Okay, so this is combining a few different things that we've learned all in one. All right, so let's look at the next one then. X to the fourth minus 13x squared plus 36 is equal to 0. So how could we solve this one? If we can write it as a quadratic, we can solve it by factoring or quadratic formula. So how could we write this one as a quadratic? Okay, so let u equal x squared. So if u is x squared, what do I have then? Yeah, u squared minus 13u plus 36 is equal to 0. Can we factor this one? Yeah, this factors. What does this factor to? U and u minus 9 minus 4. So what do my two values for u here equal? Yeah, u equals positive 9 and u equals positive 4. But what's my original variable? My original variable are x's, so if u is equal to x squared, now we have to replace the u with the x squared. So we have x squared is 9 and x squared is 4, because we want to ultimately solve for our x's. Well, if x squared is 9, what is x for this one? Not just 3, because you take the square root, it's plus or minus 3. And then how about for the x squared is 4? Plus or minus 2. So there would be our solutions.
So your u equals 9 because you just swapped the...
We solved. U minus 9 is equal to 0, so u should be 9. Is that okay? All right, let's do two others. Number 7, x to the 2/5 minus 6x to the... x to the 2/3 minus 6x to the 1/3 plus 5 is equal to 0. Okay, so how could I write this so that I can get a quadratic, which we could solve for a little bit easier? What do we want to let u equal? Two-thirds and one-third. Is one-third half of two-thirds? Yeah, okay. So what should we let u equal then? Yeah, x to the one-third. So if u is x to the one-third, what will be my quadratic now in terms of u? Yeah, u squared minus 6u plus 5, good, is equal to 0. Can we factor that? That can be factored. How can we factor this?
U is U minus 5
Good, u minus 5, u minus 1. So what are my two values that u can equal? Yeah, u can be 5 and u can be 1. Yep, but we don't really want u here. We want x to the third because that's what we let our u equal to. So you go, okay, so x to the 1/3 is 5, or x to the 1/3 is 1. How do we get rid of the x to the 1/3? Do we have to do what with it? Raise it to what power? Raise it to the third power, so we raise the other side to the third power as well. Same thing for this one, raised to the third power, so we raise the other side to the third power as well. Raising this to the third power would give us just an x. So here x is equal to, well, what's 5 cubed? 125. And what's 1 cubed? 1. So x is 1 or 125. Is that okay? Bless you. All right. Let's do this one with square roots in. X minus 6 to the square root of x is equal to 7. What power is a square root? It's a half. Remember that? Square roots are the same thing as a half. So this will work. A half and 1/2 is half of 1. Should I maybe get this equal to 0 first, though? Probably. And so we'll have to minus the 7 over. And then what will my u have to be here? Yep, so let u equal either x to a half or square root of x. It doesn't matter which way you think about it, you're going to get the same answer. So then as a quadratic, what would this be? U squared minus 6u, and then we have to remember to subtract the 7 over, so minus 7 is equal to 0. And now how can we factor that? Yep, minus 7 and plus 1, so u minus 7 times u plus 1 is 0. So then what are the two solutions here for u? So u is 7 and u is negative 1. Well, what's the u really? Square root of x. So square root of x is 7, and square root of x is negative 1. How do you get rid of the square root? Square. So what is the value here? 49. And now look carefully. This other one is saying square root of x is negative 1. Is that possible? No. So that does not work, so we just have 49. We can take the square root of a negative number, but a square root won't give us a negative number. Yep, you could also let u be x to the half. That's fine. Yep. This square root of x is the same thing as x to the 1/2. There's two of those in there, so it would be u squared. Is that okay? And that's just another example like this one. So